My name is Katie Little, and for my Unit 4 project, I'm making a video to explain a couple of the concepts we've learned about the nervous system in the past 4 chapters. And in order to do that, I would like to use reflexes as an example to explain a bunch of things, actually. So, let's begin. One of the reasons I like reflexes is that they can help illustrate a lot of things, and I've made a few slides as visual aids so you don't just have to watch me the whole time. And reflexes can help illustrate mainly the divisions of the nervous system, so somatic versus autonomic, motor versus sensory, and they can also help represent, I think especially the autonomic reflexes, homeostasis very well. And I think they can help illustrate some of the actions of cranial nerves and illustrate that they are not just motor but also sensory, and different actions of different muscles as well, smooth and cardiac versus skeletal. And let's see, what's the last one? Yes, different types of neurons, especially interneurons, which becomes very interesting, I think, in reflex actions. So, I have used several sources for this video, mainly the textbook by Saladin and Professor Huston's lectures online, and also a website from Rice University, and I will be citing those at the very end. So, and forgive my voice, I'm starting to lose it, so bear with me. So really I'd like to, in this video, address 3 questions, and those are: what are reflexes? What is a reflex? What different kinds of reflexes are there? And then the third one, and mainly the most important, how do reflexes help me? Why should you care? Why should you care about reflexes at all? So I hope I address these by the end of the video. And I'd like to talk about 4 main things about reflexes. All reflexes are involuntary. They are not spontaneous. And that's good, because we don't want reflexes happening without any provocation whatsoever. We want them to be a response to a stimulus. Reflexes are fast, and for somatic reflexes especially, they are extremely fast. Autonomic a little slower, but in comparison to voluntary movements, reflexes are quick. And that's also good, because if a reflex is helping you, say, avoid injury, you want it to be really quick. And reflexes are not voluntary. This might be a little bit hard to understand with the somatic reflexes. Just because reflexes are not voluntary doesn't mean we are not consciously aware of them. Somatic reflexes we are consciously aware, but we don't have to think before we do it, which again is good. If a reflex is helping you avoid injury or avoid further injury, you don't want to have to think about it before you, pull your hand away from the hot stove is the classic example. And then finally, reflexes are stereotyped, meaning that they tend to happen the exact same way every time, or at least a very similar way every time. And that's also good. You don't want reflexes to be unpredictable. If, you get hit in the knee, then your leg should kick out. It's not like your elbow is going to kick out because you got hit in the knee. So, those 4 things having to do with reflexes. And reflexes, in general, they follow a basic arc in the body. And I have another slide here for that. The very first thing is that there will be some sort of receptor, whether this is a somatic, so dealing with skeletal muscle, or whether it's autonomic, so maybe it's in your stomach, smooth muscle lining the intestinal wall. You have some sort of nerve receptor in those organs that is going to send a signal. And it's going to send a signal via an afferent nerve, more on that later, to an integrating center, which often involves interneurons, and the integrating center is either in the spine or in the brainstem. Sometimes reflexes are referred to as spinal reflexes, but that's not entirely accurate, because a lot of them, both somatic and autonomic, they do go through the brainstem, not just the spine. And so once a decision is made effectively by these neurons via synapses, if you remember that from earlier on, the signal back to the organ will be sent via the efferent nerve, and then it will be sent to an effector. And what that effector is depends on what kind of reflex it is. So really, what is a reflex? I haven't really, said that yet. A reflex is an involuntary response by a muscle or a gland to a stimulus. and it occurs via the nervous system. That's the pathway I just showed you. And somehow it serves an important purpose to the body, whether that is making sure your posture is all right, whether that is going through with digestion, or even helping you to breathe or to lower your blood pressure, and whether it's helping you avoid injury, which is what people tend to think of when they think of a reflex. They think of putting your hand on a hot stove and jerking it away before you know what's happening. So, I've shown you the 4 different characteristics of a reflex and the regular reflex arc. So what I want to do now is just do a very brief overview of the divisions of the nervous system in general. So refresh your memory a little bit. So I've got here just nervous system at the top, and then it divides into the central nervous system, which is the brain and the spinal cord, and then the peripheral nervous system, which is everything else, every other nerve in your body innervating every bone, muscle, tendon, organ. And then the peripheral nervous system is divided into 2 sections as well. There's the somatic and then the autonomic. And the autonomic is sometimes referred to as visceral, meaning internal organ. And so somatic is what we tend to think of as under our conscious awareness, so skeletal muscle so we can move voluntarily. And remember I said that reflexes themselves are not voluntary, but we do have, if it's a somatic reflex, conscious awareness of it, even if it's just after the fact. And then each of these divisions, the autonomic and the somatic, are divided up as well into sensory and motor pathways, also called afferent and efferent. And sensory is taking a stimulus from, say, your eye or your pain receptors in your skin, and then bringing it towards the central nervous system. So away from the stimulus and towards the central nervous system. And then efferent, or motor, would be taking that information from the central nervous system and then putting it out back into the peripheral nervous system, into the body. And I think I have an asterisk by sensory here and autonomic because some people group sensory all by itself and then just have autonomic be motor. But I think it makes more sense if you put sensory and motor for each of these divisions. So, little review. Let's see here. I've got my notes. Oh, one little thing about the integrating center. I mentioned it can either be the spine or the brainstem. And the integrating center tends to involve very few interneurons. It can involve many, but generally it's very few because you don't want the reflex to take a long time for obvious reasons. If it's protecting you, you want it to go very fast. So generally there are very few interneurons in the integrating center. Okay, and now I have some other figures for you, and these figures have been copied out of the different resources that I have used. The first one is from Rice University's website on the autonomic nervous system, and it's comparing somatic and visceral reflexes. I don't know if you can see here. And they're basically the same, really. They're showing a cross-section of the spinal cord for each. The top one is the visceral, or the autonomic, and the bottom one is the somatic, the skeletal muscle. And notice that especially for the afferent, which they're not really showing here, the afferent neuron, it's basically the same in both systems. You have an afferent neuron that acts as a sensory organ, and some signal is sent, whether it's light or pain, and it comes back to the central nervous system, which again they're showing as the spine. It could be the brainstem too. And really the difference between autonomic and somatic reflexes is in the efferent pathway, the way from the central nervous system back to the organ that's going to affect the response. And so, hopefully you can see this here. For the autonomic pathway, you have a neuron, starts off in the spinal cord. Here's an interneuron, and then the efferent neuron coming here. One of the big differences is that there are ganglia in the autonomic nervous system, so it takes a little longer. Reflexes in the autonomic nervous system take a little longer than somatic reflexes would, because you have that little delay, another synapse there by the ganglia. And then the effector organ is obviously different from the somatic. Here it's smooth muscle, but it could also be a gland or cardiac muscle for autonomic. And notice that the neuron, once it reaches the effector organ, there's not necessarily a synapse. It's not that the nerve ends right there, but it does have a varicosity, so a little bulge in the axon and letting out neurotransmitter via synaptic vesicles. So here's another blast from the past as far as the nervous system goes. And down here they show the somatic nervous system. That's in the frame. And so it's a little bit simpler. We really only have one neuron, being the efferent neuron, instead of having that little gap at the synapse in the ganglia. And it goes out to the effector organ, which for somatic reflexes is always a skeletal muscle. And it does end at a synapse, and it's sending out neurotransmitters to effect the response to the muscle. And I think an important thing to remember here too is that the reflex can either excite the muscle or it can inhibit the muscle. The neurotransmitters can cause either an EPSP, which is an excitatory postsynaptic potential, or an IPSP, which is an inhibitory postsynaptic potential. So reflexes can go both ways. They could either excite that particular muscle or they could inhibit it, and more on that later. So there's just some of the differences between autonomic and somatic reflexes in a nutshell. And let's see, back here. So first, before I get into the various kinds of somatic reflexes, I would like to show you an autonomic one first. I think it's because people are less familiar with autonomic. When you think of a reflex, you think of going to your doctor's office and they hit you with a little hammer and your knee jerks, right? But reflexes are a lot broader than that, and reflexes control everything in our body from blood pressure, blood sugar, heart rate, breathing rate, all these things that are really essential for our survival, and these are all going on, these autonomic reflexes, without our conscious awareness and without our conscious control. And again, that's a good thing, because there are times when we are unconscious. Every night when we go to sleep, we don't want our heart to stop beating, because we shouldn't have to think about it. That would be bad. Okay, so here is an autonomic nervous system reflex, and this is taken out of Saladin, I believe chapter 15. And this is showing a baroreflex, so this is dealing with blood pressure. And right here you can see this arc that this person's blood pressure is too high. And so there are baroreceptors, nervous receptors that detect changes in pressure. And they are in the carotid artery, which is coming off the aorta. I think it's coming up through here. And these receptors, they send a signal via the afferent nerve. And this particular afferent nerve is the glossopharyngeal nerve. That's cranial nerve number 9. We also learned about those. We learned about the brain. And it's sending this signal back to the brain stem, specifically the medulla oblongata, and it's saying, hey, make a decision here. What the blood pressure is too high. What should we do? And so I think they only show one little interneuron here. There could be many more, but probably not that many. And the efferent nerve, going to the effector organ, is the vagus nerve, which is also a cranial nerve 10. And it is going to send a signal down to the SA node in the heart, which is the effector organ, and that is going to slow down the heart rate. So for whatever reason, this person's blood pressure is too high, and they need it to go down. So glossopharyngeal nerve acts as the sensory nerve, and then the vagus nerve acts as the motor nerve. And it says to the SA node of the heart, beat slower. And it does. And I think this is really important in maintaining homeostasis for the body. These autonomic reflexes help to maintain homeostasis. And to remember, too, that homeostasis is a dynamic equilibrium. It is not just one straight line. It's not like your blood pressure is always, 120/80. It fluctuates, but just a little bit. When it gets too high, it's brought down low. When it gets too low, it's brought down up again. So you have homeostasis, but within an acceptable range. And the autonomic reflexes help you do that. Okay, so now I'd like to move on to somatic reflexes. So these are the ones we're more familiar with. And there are several types, but I'd just like to show you basically what happens. So I've got another figure from Saladin here, figure 1320. And this is showing the classic doctor's office knee-jerk or patellar reflex. So you've got your afferent nerve fiber coming up from the muscle. The first thing you do, the doctor, he hits you with the mallet, and there are receptors in the tendon, the patellar tendon, for your quadriceps femoris muscle, and they detect this sudden stretch. And these afferent nerve fibers carry a signal up to the posterior cord for the spinal nerve, and it goes to the spine, so this is what we would call a spinal reflex. And then they send a signal down through the efferent nerves, and what it does is it excites the quadriceps femoris muscle. So it's sending an EPSP to the quadriceps femoris that says contract. And this is all in a very short space of time. You know, the doctor hits your knee and you kick, right? And it's all because of this somatic reflex and these stretch receptors in your patellar tendon and this somatic reflex loop. So anyway, that's sort of the basic criteria for a somatic reflex. And so somatic reflexes in general, there's a couple different types. The one that I just mentioned is the stretch reflex, and that's also called the myotatic reflex. And that is the stretch receptors in the tendons and in the muscle that they tell when the muscle is stretched a little bit too much, and the muscle kind of fights back in a way. This reflex